Hello everyone, welcome to the C programming course CS100, and today we are going to go through C program compilation process. So when we write a C program, behind the scene, how is the compilation process happening? So it is 1.1 Lab C program compilation process. So when we look at the C compilation process, it passes through several stages. Once our high-level program or high-level language is written using an IDE, integrated development environment of our choice, it will be pre-processed first. Okay? So that pre-processors will be appended to the program, and then it went through a compilation process, assembly, linking, and finally the executable code is going to be generated. Today we are going to see how all these compilation stages happen behind the scene. Okay? In step 1, we are going to write the source code. We will write a really simple hello program. So I will go ahead and open a notepad editor. We will write a program here. Okay? So again, when we write the program in any notepad editor or any editor of your choice, the first thing we need to include is the preprocessor directives. I'm going to go ahead and include stdio.h. And then I will go ahead and start the main programming page. And we are going to do the simple traditional hello world program, or let's just do addition of two numbers for now. Okay, I will go ahead and define two variables, num1 and num2, and I will also define result. So I defined three variables, num1, num2, and result. And now I'm going to ask the user to enter the two numbers. Print enter number 1 scanf %d. This is going to capture number 1 from keyboard, and I will go ahead and do the same for number 2. And then we are going to do calculation, so that the result is going to be num1 plus num2, and then we just print the result. Okay, %d plus %d equals %d. I'm going to use format specifiers to ensure proper formatting here, so that num1, num2, and result are going to be substituted. As you can see, this is a program we just want, and we will have time 0, and I will close the curly brace. Okay, now we just make sure I'm having this. I'll go ahead and tab each of these individual ones to make sure our code is clear. Okay, here we go. Now I'll go ahead and save this file, save as. I'll save it to my desktop, and I already created a program, a folder called programs. I will go ahead and put this as mail.c. Okay, and I'll go ahead and save it. It is now saved as main.c. Okay, now I'll go ahead and open command prompt so that we're going to see what can be done with our file. Okay, so once our step 1, writing the source code, is done, the second thing we are going to do is, if I just do cd right now, okay, and hit enter, I am in my GETAC drive, and if I do dir, you can see that desktop is part of this. So I'm going to change my drive into desktop first. Okay, cd desktop. Oops. Now I'm in my desktop, and then I'm going to change my directory again to programs folder. I am in programs folder now. If I do dir now, you can see that there is one file we just created, main.c. Okay, this is the file we have created. Now we know that our program is in programs folder in C drive. Now we will go ahead and do pre-processing on this file. Okay, pre-processing on this file, so that the preprocessor directives will be appended to our program and converted to main.i file. In order to do that, we are going to write, I'm going to use the GCC compiler now. Okay, main.c, and then we are going to create main.i file, which has the preprocessor directives appended to it. Now we have already done that. If I do dir now, you can see that main.i is now created. If I open this folder, I'll go ahead and open the folder so that we will go ahead and see it. So now we have our main.i file. If I open it, you can see that stdio.h, several of the preprocessor directives necessary to execute this main.c file are already included here. That's the first step. This is pre-processing step. Once the pre-processing step is finished, we are going to proceed to the compilation step. Okay, so this compilation step is going to convert the pre-processed file into an assembly code. So in order to do that, again, we are going to use our GCC compiler. Okay, GCC. We are going to give main.i as an input, and then we expect the output to be main.s. It is an assembly code now. Okay. Now, as you can see, during this assembly code, our compiler is going to look if there is any syntax error. As you can see here, print actually has a syntax error. Let's go ahead and fix this first. I will open the main.c file and I'll change this guy to F. I'll go ahead and save it. Okay. And I will do the pre-processing first, just to make sure we're doing the right thing. And then I will follow okay. Line 6, 9. There's one more place I did not change. Let's go ahead and fix those. Open printf. Okay, the rest is fine. I'll go ahead and save it again. And I will do the pre-processing step first. And I will do the compilation now. Now there is no error. If we do the IR again, now we will see main.s file. If I open this main.s file, you can see that this is an assembly code. Okay. So assembly is again another low-level programming language, which is very close to hardware. So the program now is converted to this low-level assembly code. So this step is compilation step. Once our compilation step is done, the next task is going to be assembly step. In this assembly step, the assembler is going to take the assembly program and converts this assembly into a machine language instruction. Okay, and this machine language instruction is going to be an object code, so it will have a .obj extension or .o extension. So right now we are going to convert GCC. So we are going to take the main.s file and we are going to convert it to main.o file. Okay, so it will be an object code, and this object code is actually a machine instruction. We will not be able to read it, unfortunately. As you can see, our object code is now created. It is an object file. If we look at our program here, we will see a lot of gibberish now. This is actually a sequence of zeros and ones. If we use a proper reader, this is going to be zeros and ones. Okay, since we are not using a reader, we will not be able to do anything with it. Right now, our object code is generated. Now we are going to do linking. Okay, so in the next step, the linker is going to combine the object file we just created with standard libraries. For example, stdio, stdlib, conio. Several of the standard libraries are going to be combined in this linking stage. Okay, for example, we use printf and scan. So this printf is going to be linked in this step so that our final executable code is going to include all these standard libraries. Okay. So now let's go ahead and do the linking. And to do the linking, again, we are going to use the GCC compiler. So the main.o file is going to be our inputs. Okay, and then we are going to convert it to a main.exe file. Now if I do look at the folder, you can see that the main.exe file is now created, and now our executable file is ready. We can execute it. If I just do main.exe here, you will see that our program is going to execute, and it will ask us for input. Look at what happened. Enter number 1. Let's say 45 is number 1. Enter number 2. 67 is number 2. And finally, +45 +67, 112 is going to display. So this is how compilation happens in a C program. Let me go ahead and review what the entire process is now. So our source code is developed using an IDE of our choice, and then pre-processing occurs. In this step, preprocessor directives are going to be included in our program. Whatever includes instructions used at the top of our program are going to be attached here. And the next compilation step is going to occur. In this compilation step, our program is going to be compiled. That means all the pre-processed information and our actual program are going to be combined and checked for any error. Okay, and then after that, the assembler is going to assemble it, so that an assembly code is going to be generated as the output, and then the linker is going to link programs, okay, from the stdio library or from the stdlib library that we use in our function, in our program, and then we will create an executable file for us. Okay, in step 1, we write our source code. In step 2, okay, in step 2, we are going to do pre-processing. In this step, all the pre-processor directives are going to be attached to our file. In step 3, compilation is going to happen. In this step, the pre-processed file, which has a .i extension, is going to be assembled into an assembly code. Okay, and then assembling is going to occur. In this step, the assembler is going to take the .s assembly program and it converts it to a machine language instruction. In this machine language instruction, we have a .o extension, and it will be a sequence of zeros and ones. Only machines will be able to read it. The CPU is going to be able to read it. And after assembling, linking is going to occur. In this step, the assembled program, which has a .o extension, the object code is going to be linked with standard library files. Okay, and it will be converted to an executable file, and this executable file now can execute in any environment, in Windows environment or Linux, Mac environment. We will be able to execute. This is how our C program compilation occurs. I hope this helps, and I'll see you in the next video.